Hi friends, welcome back to our Control Systems Simplified Series. Today we'll be discussing about Mason's gain formula related to signal flow graphs, how to get the transfer function derived from the signal flow graphs. Suppose that there are n forward paths in a signal flow graph. The gain between the input and output nodes of a signal flow graph is nothing but the transfer function of the system. So the transfer function is nothing but C of S by R of S. C of S is the output, R of S is the input. Now if we can represent this using a Mason's gain formula, which is nothing but sigma I is equal to 1 to n pi delta I by delta. Let's understand this. Don't get confused. It's very, very simple as we go through in this, where C of S is the output node, R of S is the input node, T is the transfer function or gain between RS and CS. So T is the gain between input and output. Pi is the ith forward path gain of the ith forward path. We'll come to understand when we see it with an example. Then delta, calculation of delta is very significant in Mason's gain formula. And we calculate delta equal to 1 minus sum of all individual loop gains. We'll understand what are individual loop gains, plus sum of gain products of all possible non-touching loops minus sum of gain products of all possible 3 non-touching loops, plus and so on, it goes like that, plus sum of gain products of all possible 4 non-touching loops minus sum of gain products of all possible 5 non-touching loops. Like that, it goes on and on. And delta I is obtained from delta by removing the loops which are touching the ith forward path. Okay, and delta I is observed. So once we get delta I and delta, so it is sigma I is equal to 1 to n pi multiplied by di by delta. So let's understand this with a simple example, a basic signal flow graph in order to understand the basic terminology. This is one which we have seen. In this, we have a path which is a traversal of branches from one node to any other node in the direction of branch arrows. It should not traverse any node more than once. Let's understand, let's keep this in mind in order to understand the terminology of all these things. Okay, so this is the forward path. Okay, so examples: Y2, Y3, Y4, Y5, and Y5, Y3, Y2. You have, this is one, Y5, Y3, Y2. So this is nothing but the path, right? More than once it should not traverse from, so we are getting that. Then let's understand what is the forward path. In this, what is the forward path? The path that exists from one input node to the output node, Y1 to Y6. This node, this is known as forward path. So we have from Y1, Y2, Y3, Y4, Y5, Y6. This is one forward path. So another forward path is Y1, Y2, Y3, Y5, it is jumping. This is another thing. This we have already traversed. Y5 and Y6. So we have two forward paths in this. Then we have forward path gain. Forward path gain is obtained by calculating the product of all branch gains of the forward path. Okay, so branch gains, this is the forward path, right? y1, y2, y3, y4, y5, y6 is the forward path. So the product of all the gains of this product path. So that is nothing but A into B into C into D into E. A, B, C, D, E is the forward path gain of this forward path. Then we have another forward path, y1, y2, y3, y5, y6. Okay. So for this, the product of this is A into B into G into E. A, B, G, E is the forward path gain of this equation. Then let's understand loop. What is the loop? Loop is the path that starts from one node and ends at the same node, and it starts at one end and ends at the same node, and that is what we call as a loop. So because it starts from one point and ends at the same point, we call it as a loop because it's a closed path. So example here is y2, y2, y3, y2. This is one loop. We have y2, it's starting from the same point and again ending at the same point. So y2, y3, y2 is one loop. Then another loop is y3, y5, again y3. This is also another loop. y3, this is coming y5, y3. Okay. So this is another loop. So we have two loops in this. Then what is the loop gain? Loop gain is obtained by calculating the product of all branch gains of a loop. Example, Bj, B for this loop, y2, y3, y2, the loop gain is B into J. Okay, Bj is the loop gain of y2, y3, y2. And for y3, y5, y3, y5, y3, the loop gain is GH. G is the gain of this and H is the gain of y5, y3. G is the gain of y3, y5 loop. So then another terminology is non-touching loops. So non-touching loop are nothing but these are the loops which should not have any common node. There should not be any common load. In that we call them as non-touching loops. So the examples are the loops y2, y3, y2 is one loop. Then y4, y5, y4. So these two are non-touching loops. So this loop and this loop, there is no touching of the thing. So any other loop, y3, y5, y3, touching y3. So this cannot be a non-touching loop. So if you take again y5 to y5, this is again touching y5, right? So y2, y3, y2, and y4, y5, and y4 are the non-touching loops. Now let's consider the same signal flow graph for finding the transfer function. If you have to find the transfer function for this, now let's see number of forward paths. How many forward paths are there? One forward path, y1, y2, y3, y4, y5, y6, and y1, y2, y3, y5, y6. These two are the forward. So capital N is nothing is equal to 2. And then first forward path is, what is the first forward path? y1, y2, y3, y4, y5, y6. First forward path gain is nothing, P1. Okay, first forward path gain is equal to A into B into C into D into E. This is what we have seen. Okay, first for gain of the first forward path y1, y2, y3, y4, y5, y6. Then second forward path y1, y2, y3, then it is going like this, y5 and y6. So the gain of the second forward path P2 is the gain of the second forward. That's what we have seen. Pi is nothing but ith forward path we have seen. So P2 is the second forward path gain. For the second forward path gain is A into B into G into E. This is exactly it. Now, how many number of individual loops are there in this? L is equal to number of individual loops. How many individual loops are there? Y2, Y3, Y2. One loop. Y3, Y5, Y3 is second loop. Y3, Y4, Y5 and Y3. This is another loop. Third loop. Fourth loop is Y4, Y5 and Y4 is fourth loop, and fifth loop is Y5, again coming back to 5. So there are 5 individual loops. So capital L is nothing but 5. Now what are the loop gains? So L1, what is the loop 1? L1, Y2, Y3, Y2 loop gain is B into J. Then L2 is equal to, loop 2 is equal to Y3, Y5, Y3. So for this, the loop gain is G into H. G into H. Now the third loop is Y3, Y4, Y5 and Y3. So for this, the loop gain is C into D into H. C into D into H is the loop gain of Y3, Y4, Y5 and H, this loop gain. So then L4, we have Y4, Y5 and Y4. Loop 4 is equal to Y4, Y5, Y4. This is the fourth loop. So for this, the loop gain is D into I. And lastly, the fifth loop, Y5 to Y5, the gain is F. Now here, what are the number of two non-touching loops? There are two non-touching loops here. We have already seen. So the first non-touching loop is Y2, Y3, Y2. The second non-touching loop is Y4, Y5, Y4. Okay. So gain product of first non-touching loop pair. First non-touching loop pair. Okay. So L1, L4. Okay. First non-touching loop pair. So this is BJ. This is DI. So non-touching loops are Y2, Y3, Y2. This is BJ. And Y4, Y5, Y4 is DI. So the gain product of first non-touching loop pair is L1 into L4, that is equal to BJ into DI. So second non-touching loop pair is Y2, Y3, Y2 and Y5. This is the second non-touching loop. Okay, so the gain product of the second non-touching loop pair, just remember, this is the gain product of the second non-touching loop pair is BJF, right? BJF. So here, this is what we need. Here, the number of, that is more than 2 non-touching loops are not present in the signal flow graph, so that we will not have the lost terminology. If you see the equation of this example, we are having path, forward path gain, we have already seen, then loop gain, non-touching loops, then the transfer function using Mason's gain formula, number of paths n is equal to 2, first forward path we have seen, P1 first forward path gain we have seen, second forward path gain, number of individual loops 5. What are all those loops here? And loop gains are L1, L2, L3, L4, L5. This we have seen. Then we have also seen number of two non-touching loops are 2. First non-touching loop pair is this. Gain product of the first non-touching loop pair is BJDI. Second non-touching loops is Y3, Y2, Y2. and y5, y5. Gain of this is bjf. Now, if you see the delta, what we ultimately Mason's gain formula is nothing but sigma I is equal to 1 to n p n pi I is equal to 1 to n pi delta I by delta. So in this equation, just remember this equation. In this equation, delta is equal to 1 minus sum of all individual loop gains. Sum of all individual loop gains. So we are saying substituting the values in the above equation, 1 minus what are all the individual loop gains we have seen here, bj plus gh, this loop, this loop, this loop. So bj plus gh plus cdh plus di plus f, sum 1 minus sum of all individual loop gains. Sum of what are all the individual loop gains? Let's see in this individual loop gains. Okay, so this is 1, this is 2, this is 3, this is 4, this is 5. So sum of all this is, first one is bj, second one is cdh, second one is gh, like that. Okay, so that's what exactly we have written here. First one is bj, then gh, then cdh, then di plus fi. That's what is the second term. Sum of gain products of all possible two non-touching loops. Now we have to see the sum of gain products of all possible two non-touching loops. So how many non-touching loops we have? bj di into bjf, non-touching loops we have seen. Okay, bj di in this, bj di is the non-touching loop, then bjf. These two are this one and this one is one non-touching loop pair, and this one are the first non-touching loop pair. This and this are the second non-touching loop pair. So bjf. Okay, so that's what we see here. bjdi plus bjf. So sum of gain products of all possible two non-touching loops. Then minus sum of gain products of all possible three non-touching loops. So in this equation, if you see, there are only two non-touching loops. There are no three non-touching loops. Pair is not there. Three non-touching loop pair is there. Only two non-touching loop pair is there. This one and this one, this one and this one. So there are no three non-touching loop pair at all. So there are no three loops which are non-touching in this. If you see of the 5 loops, any two are touching. Only this one and this one and this one are two non-touching loops. So that is exactly what we have. So sum of gain products of all possible three non-touching loops is 0 in this. So this implies, once we substitute this, now we will see delta is very simple. Okay, whatever we do, we have just substituted this. So delta is equal to 1 minus bj plus gh plus cdh plus di plus f plus bj di plus bjf. Okay, now delta, what is delta I? There is no loop which is non-touching to the first forward path. Okay, so delta I is equal to 1. Delta 1 is equal to 1. That is exactly what we see here. So all the loops are touching the first forward path. Okay, so what is delta I we have seen in this? If we see delta I in this, in the same equation, delta I, pi is the ith forward path we have seen. Delta I is obtained from delta by removing the loops which are touching the ith forward path. That is delta 1 if you want to get. Delta 1 if you want to get, that is the first forward path. Now in this equation, we have the first forward path y1, y2, y3, y4, y5. So all the loops are touching the first forward path. Okay, so delta I is taken as 1. Delta I is taken as 1. So delta 1 is equal to 1. Similarly, delta 2 is equal to 1 since no loop which is non-touching to the second forward path. All the loops are touching to the second forward path also. So delta 2 is equal to 1. So now we have, if we substitute this pi delta 2 taking n is equal to 2 because we have two loops. So we have the transfer function C of s by R of s is equal to sigma I is equal to 1 to 2 pi delta I by delta. Now this, because I is equal to 2, we get the same transfer function p1 delta 1 plus p2 delta 2 by delta. This is exactly what we get from this equation. Sigma pi delta I is nothing but when I is equal to 1 to 2, p1 delta 1 plus p2 delta 2. If I is equal to 1 to 3, p1 delta 1 plus p2 delta 2 plus p3 delta 3 will get by delta. Because we have only two loops, we got this. Now substitute all the necessary values in the above equation. Now P1, what is P1? We have A, B, C, D, E is P1. We have calculated. What is P1? Here we have calculated. P1 is A, B, C, D, E. Okay, first forward path gain. P2 is second forward path gain, A, B, G, E. That's exactly what we are doing here. So A, B, C, D, E is the P1, delta 1 is equal to 1, then plus P2 is equal to A, B, G, E, again delta 2 is equal to 1, divided by delta, we have already calculated delta here, 1 minus Bj, Gh, all these things. That is exactly what we did. 1 minus Bj plus Gh plus Cdh plus. So the transfer function T is equal to C of S by R of S is equal to ABCDE plus ABGE divided by 1 minus Bj plus Gh plus Cdh plus Di plus F plus Bjdi plus Bjf. That is, so the overall transfer function of the signal flow graph which we got is T of is equal to C of S by R of S. This is the transfer output by input that is given by ABCDE plus ABGE divided by 1 minus Bj plus Gh plus Cdh plus Di plus F plus Bjdi plus Bjf. Now this is how we can find out the transfer function of a typical signal flow graph using the Mason's gain formula, which is equal to sigma I is equal to 1 to n pi delta I by delta. So this is exactly what we have done it with an example. Hope it is clear to you. If it is not clear, please go once again through this video, then it is explained very lucidly to understandable to all. If you go through once or twice, Mason's gain formula is very, very simple to explain. So that's all about it. Thank you very much.